And now, resistor networks, level 3. Let's try a problem. Okay, total resistance 24K79. What's the unknown resistor? Well, first thing to note is that we've got 20K here, and if the total resistance is 24.79K, then the total resistance of these three resistors must be 24.79K minus 20K, or 4,790 ohms. Now, the 4,790 is the parallel combination of 10K and whatever is here. So we can work out the total of these two using the formula for resistors in parallel. And that, as a reminder, is 1 over the total resistance here, which in this case is 4,790, must be equal to 1 over 10K plus 1 over X, where X is the series combination of these two. Well, we can solve this equation, and that would just be X is 4,790 times 10K over 10K minus 4,790, and quickly evaluating that, 4,790 times 10K divided by 10K minus 4,790 is 9193.86. So 9193.86 is the series combination of those two. So to work out what this resistor must be, it's just 9193.86 minus 5K6. Close enough. You won't get the exact answer when you do problems like this, because the total resistance wasn't exactly 24.79. There would have been a few decimal places down here that weren't printed out, but you'll get the answer marked correct because you're close enough. They get a bit trickier, these. Let's have a look at another one. Okay, here we've got three resistors in series, and again you can't move them, but you can change their value. And it's asking you, using E24 values, to get a total of 729K. Again, you need to know what the E24 values are, and then solve this puzzle. What three of them can you add together to get 729K? Well, there are several ways to do problems like this, but one approach is to note that you don't have to get the answer exactly correct. There is a margin of error that the quiz will allow you to have. So I could, for example, we're trying to make 729K. What's the biggest value, which is an E24 value, which is just below that? And the answer would be 680K. You could look that up on tables of the E24 series. So I would need another 49K. What's the biggest value below 49K? Answer 47K. That would leave me with 2K, but actually that's good because 2K is an E24 value. So a series combination of 680, 47 and 2 should do just fine. There are often multiple ways to solve these problems, but this is a way that I've found does help get to solutions in many cases. Again, press the button to submit. Yay. Oh, let's try another one. Make the resistance equal to 1 meg 51 ohms, and this time we've got 3 resistors, but actually this one's quite easy, because the only way we can get anywhere near 1 meg 5 is to add up the 3 resistors in series. I don't even have to think too carefully about whether that gives the correct answer, because there's no other way I'm going to get anywhere near 1.5 meg. It must be right. And it is. And I get a really good score, 80 for it. Try another one. Okay, total resistance 4881. What is the unknown resistance? Similar approach to what we've used before. We've got an unknown here, a 430 here, a 1K8 here, and a 2K there. Right. This is the parallel combination of these two. These two added together is 3K8. I can replace them with a 3K8 resistor. I know that the total resistance is, just check, 488.1. So I can put that into the formula that we've used before. The total resistance is 3K8 times the unknown resistance divided by 3K8 plus the unknown. Actually, this would be unknown resistance plus 430. The unknown resistance plus 430. Bit of algebra on that, and you'll end up with the unknown resistance plus 430 is equal to 488.1 times 3K8 divided by 3K8 minus 488.1. That's what we're going to try and solve, and that will give us the unknown resistor plus 430, the total resistance of this series combination here. Let's work out what that is. Well, that's going to be 488.1 times 3K8 divided by 3K8 minus 488.1, and that gives you 560.035, and the answer therefore must be 560.035 minus 430. Just as a reminder, you can just type x minus 430 because typing that in this box down here puts its value equal to x. Hooray! I'll just do one more. Right, here we've got 4 resistors in parallel. So you have to know the extension to the equation for lots of resistors in parallel, and that is that 1 over the total resistance equals 1 over the first one, plus 1 over the second one, plus 1 over the third one, plus 1 over the fourth one, and so on. Now, in this particular case, the total resistance is, I forgot, hang on, 2K508, and the resistors that we know are 11K and 18K and 6K2, and then there's one unknown one. Well, from that it's fairly easy to work out what 1 over the unknown resistor must be. It's just 1 over 2K508 minus 1 over 11K minus 1 over 18K minus 1 over 6K2. And if we work out all of that, that would be back here. 1 over 2K508 minus 1 over 11K minus 1 over 18K minus 1 over 6K2 is that. And that is 1 over the unknown resistor there. So if we just go 1 over x, because this has now been evaluated and put equal to x, it's in this x box, 1 over x would be within the accuracy to which you can work. That is equal to 11,000. So we could be fairly confident that the unknown resistor is another 11K resistor. And indeed we would be right. Okay, that's level 3. Level 4 this time, I'll leave to you.